Hello and welcome. I'm so glad you're here tonight. Whether you're settling into bed after a long day or simply looking for a peaceful escape, you've found the right place. Over the next couple of hours, we're going to journey together through one of Earth's most mysterious and beautiful realms, the ocean. There's something deeply calming about the sea, isn't there? Maybe it's the rhythmic sound of waves or the endless blue that seems to stretch into infinity. Tonight, we'll explore 100 fascinating facts about our oceans, but there's no need to remember them all. Just let the words wash over you like gentle waves on a shore. If you drift off halfway through, that's perfectly fine. That's exactly what this is for, so go ahead and get comfortable. Adjust your pillow, pull up your blanket, and let's begin our journey into the deep blue. The ocean covers more than 70% of Earth's surface, yet we've explored less than 5% of it. Think about that for a moment. We know more about the surface of Mars than we do about the deepest parts of our own ocean. There are mountain ranges down there taller than the Himalayas, canyons deeper than the Grand Canyon, and creatures we've never seen. The ocean holds secrets that have existed since before humans walked the Earth, and most of them are still waiting to be discovered. It's humbling, really, to think that right now, at this very moment, there are entire ecosystems thriving in the darkness. Completely unknown to us, the ocean contains about 321 million cubic miles of water. If you tried to count every drop, even if you counted 1 drop per second, it would take you billions upon billions of years to finish. But here's what makes this even more extraordinary. Every single molecule of that water has been on Earth for billions of years, cycling through rain, rivers, clouds, and living creatures. The water you drink today might have once been part of a dinosaur's drink, or fallen as rain on Cleopatra's garden, or frozen in an Antarctic glacier. The ocean connects us not just across space, but across time itself. The Pacific Ocean is so vast that all the continents on Earth could fit inside it, and there would still be room left over. It covers more than 60 million square miles. If you started swimming from one side to the other, even at an Olympic athlete's pace, never stopping to eat or sleep, it would take you years to cross. The Pacific is larger than all the land on Earth combined. Ancient Polynesian navigators crossed this immense expanse in wooden canoes using nothing but the stars, wave patterns, and the flight paths of birds to find their way. They understood the ocean in ways we're only beginning to relearn today. The deepest part of the ocean is called the Challenger Deep, located in the Mariana Trench. It plunges down nearly 7 miles below the surface. If you took Mount Everest and placed it at the bottom of the Challenger Deep, its peak would still be more than a mile underwater. The pressure down there is immense, more than 8 tons per square inch, enough to crush a submarine like a tin can. Yet life exists even there. Strange, pale creatures that have never seen sunlight drift through the eternal darkness, perfectly adapted to conditions that would kill us instantly. Life, it seems, finds a way, even in the most impossible places. The ocean produces more than half of the world's oxygen. You might think of the Amazon rainforest as the lungs of the Earth, and in many ways it is. But the ocean's contribution is even greater. Tiny organisms called phytoplankton, microscopic plants that drift in the sunlit surface waters, perform photosynthesis just like trees do. They're so small you'd need a microscope to see them, yet collectively they produce more oxygen than all the forests on land combined. Every other breath you take comes from the ocean. Right now, as you breathe in slowly and deeply, thank the sea for that gift. Ocean water is salty because of minerals that have washed into it from land over millions of years. Rivers carry tiny amounts of dissolved minerals and salts from rocks and soil. Over geological timescales, these minerals accumulate in the ocean, while the water itself evaporates into clouds, leaving the salt behind. The process has been happening for billions of years. If you could somehow remove all the salt from the ocean and spread it evenly over all the land on Earth, it would form a layer about 500 feet thick. That's taller than a 40-story building everywhere, covering every continent. The ocean has an average depth of about 2.5 miles, but it's not evenly distributed. There are shallow coastal shelves where the water might only be a few hundred feet deep, and then there are abyssal plains, vast flat regions of the deep ocean floor that stretch for thousands of miles at depths of 3 to 4 miles. And then there are the trenches, those narrow gashes in the Earth's crust where tectonic plates collide and one slides beneath the other, creating chasms that plunge to extraordinary depths. The ocean floor is as varied and dramatic as any landscape on the continents above, with its own mountains, valleys, volcanoes, and plains. Waves are created by wind blowing across the surface of the water. The size of a wave depends on 3 things: the speed of the wind, how long the wind blows, and the distance over which it blows, which scientists call the fetch. A gentle breeze creates ripples. A stronger wind sustained over a long distance creates the large swells that surfers love. But the most powerful waves, tsunamis, aren't created by wind at all. They're generated by underwater earthquakes, volcanic eruptions, or massive landslides. A tsunami in the open ocean might be barely noticeable, just a gentle rise and fall of the water's surface. But as it approaches shallow coastal waters, it slows down and builds up, sometimes reaching heights of over 100 feet. The ocean has its own weather patterns, separate from the atmosphere above. There are currents that flow like rivers through the sea, carrying warm or cold water thousands of miles across ocean basins. The Gulf Stream, for instance, carries warm water from the Gulf of Mexico all the way to northern Europe, making countries like Ireland and England much warmer than they would otherwise be at such northern latitudes. Without the Gulf Stream, London would have a climate more like Siberia. These ocean currents are driven by differences in water temperature and salinity, by the Earth's rotation, and by winds. They're constantly moving, constantly flowing, redistributing heat around the planet and influencing weather patterns everywhere. Sound travels much faster and farther in water than in air. In the ocean, sound waves can travel at about 4 times the speed they do in air. This means whales can communicate with each other across entire ocean basins. A whale singing off the coast of California might be heard by another whale near Hawaii, thousands of miles away. Before the industrial age, the ocean was a much quieter place, and whale songs could travel even farther. Now ship engines, sonar, and other human activities have made the ocean a noisier place, which can interfere with how marine animals communicate, navigate, and find food. It's something we don't often think about, this invisible pollution of sound. The color of the ocean isn't actually blue. Water itself is transparent. The ocean appears blue because water absorbs colors in the red part of the light spectrum more strongly than colors in the blue part. When sunlight enters the ocean, the water molecules scatter the blue wavelengths of light more than other colors, similar to why the sky appears blue. In shallow water near beaches, the ocean might look turquoise or green because light reflects off the sandy bottom and because of the presence of algae and other microscopic organisms. In different conditions, the ocean can appear gray, green, brown, or even red during certain algae blooms. The ocean is never just one color. It's constantly changing, constantly shifting. Like a living canvas, there are more than 3 million shipwrecks on the ocean floor. That's 3 million stories of voyages that never reached their destination, of storms that proved too powerful, of navigational errors, of battles fought and lost. Some of these wrecks are ancient, from the time of the Phoenicians or the Romans. Their wooden hulls long since rotted away, leaving only their cargoes of amphorae and anchors. Others are more recent, massive steel vessels that sank during the world wars. Each wreck becomes an artificial reef, a new habitat for marine life. Coral grows on them, fish shelter in them, and slowly, very slowly, the ocean reclaims them. In a way, nothing is ever truly lost in the ocean. It just transforms into something else. The ocean floor is spreading apart in some places and colliding in others. Along mid-ocean ridges, molten rock rises from deep within the earth, creating new oceanic crust. This happens mostly in the middle of ocean basins, which is why we call them mid-ocean ridges. The Mid-Atlantic Ridge, for instance, runs right down the center of the Atlantic Ocean, like a seam. Iceland sits directly on top of this ridge, which is why it has so many volcanoes and hot springs. The island is literally being pulled apart, with the western half moving toward North America and the eastern half moving toward Europe at about the same rate your fingernails grow. Geology happens slowly, but it never stops happening. Coral reefs cover less than 1% of the ocean floor, yet they support about 25% of all marine species. They're sometimes called the rainforests of the sea because of their incredible biodiversity. A single coral reef can be home to thousands of species of fish, invertebrates, algae, and other organisms. But coral reefs are also incredibly fragile. They require specific conditions to thrive: warm but not too warm water, adequate sunlight, clean water with the right salinity. When conditions change, corals become stressed and expel the symbiotic algae that live in their tissues and give them their color. This is called coral bleaching, and if conditions don't improve, the coral can die. Right now, coral reefs around the world are under threat from warming ocean temperatures, pollution, and acidification. We're watching these underwater cities slowly fade, and it's happening faster than most people realize. The ocean has layers just like the atmosphere. At the surface, where sunlight penetrates, there's the sunlight zone, or epipelagic zone. This is where most marine life exists, where phytoplankton photosynthesize, and where most fish live. Below that, from about 200 meters to 1,000 meters, is the twilight zone, or mesopelagic zone. Some sunlight filters down here, but it's dim and blue. This is where you start finding bizarre deep-sea creatures with bioluminescence, the ability to produce their own light. Deeper still is the midnight zone, the bathypelagic zone, where no sunlight reaches at all. And below that are the abyssal and hadal zones, the deepest parts of the ocean where only the most specialized creatures can survive. Each layer is a different world with its own unique inhabitants. Bioluminescence, the ability of living organisms to produce light, is incredibly common in the deep ocean. In fact, scientists estimate that up to 90% of deep-sea creatures can create their own light through chemical reactions in their bodies. They use this ability for various purposes: to attract prey, to communicate with each other, to confuse predators, or to camouflage themselves against the faint light coming from above. Imagine drifting in the deep ocean at night, surrounded by thousands of creatures lighting up like stars, flashing and glowing in the darkness. It's a light show that happens every night in the deep sea, witnessed by almost no one. The ocean's depths are filled with living light, a silent symphony of bioluminescent beauty. The longest mountain range on Earth isn't on land, it's underwater. The mid-ocean ridge system stretches for over 40,000 miles, wrapping around the globe like the seam on a baseball. It's nearly 10 times longer than the Andes, the longest mountain range on land. Most of this underwater mountain range has never been seen by human eyes except through sonar mapping. In places, its peaks rise high enough to break through the ocean surface, forming volcanic islands like Iceland, the Azores, and islands in the mid-Atlantic. Along its length, hydrothermal vents spew superheated water, rich in minerals, creating oases of life in the deep ocean that don't depend on sunlight at all, but on chemical energy instead. Hydrothermal vents are like hot springs on the ocean floor, but the water coming out of them can reach temperatures of over 700 degrees Fahrenheit. That's hot enough to melt lead. Yet the water doesn't boil because of the immense pressure of the deep ocean. Around these vents, entire ecosystems thrive in complete darkness, based not on photosynthesis, but on chemosynthesis. Bacteria convert the chemicals in the vent water, particularly hydrogen sulfide, into energy. These bacteria form the base of the food chain, and other creatures like giant tube worms, eyeless shrimp, and pale crabs feed on them. When these ecosystems were first discovered in 1977, they revolutionized our understanding of where life can exist. If life can thrive in such extreme conditions on Earth, maybe it can exist in equally extreme places elsewhere in the universe, like the ice-covered oceans of Jupiter's moon Europa. The ocean is home to the largest animal that has ever lived on Earth, the blue whale. Blue whales can grow to over 100 feet long and weigh as much as 200 tons. That's heavier than even the largest dinosaurs. Their hearts alone can weigh as much as a car, and their arteries are wide enough for a human child to swim through. Despite their enormous size, blue whales feed on some of the smallest creatures in the ocean, krill, tiny shrimp-like animals that swarm in massive clouds. A blue whale can eat up to 4 tons of krill per day during feeding season. Their songs, deep and haunting, can travel across entire oceans. It's hard to imagine something so large, so powerful, yet so gentle, gliding through the blue depths, a creature that seems almost mythical. There are underwater lakes and rivers on the ocean floor. These aren't made of water, though. They're made of brine, water so saturated with salt that it's denser than the surrounding seawater. This brine collects in depressions on the seafloor, forming pools with distinct shores and surfaces. If you were to dive down to one in a submarine, you'd see what looks like a lake or river, complete with waves on its surface caused by deep ocean currents. The brine is usually toxic to most marine life, but some specialized bacteria and creatures can survive around the edges. These underwater lakes are strange, alien landscapes that seem like they belong on another planet, yet they're right here on Earth, hidden beneath the waves. The ocean is believed to have formed more than 4 billion years ago, not long after the Earth itself formed. In those early days, the planet was a hellish place, covered in molten rock and constantly bombarded by asteroids and comets. As the Earth slowly cooled, water vapor in the atmosphere condensed and fell as rain. It rained for millions of years, filling the basins that would become the first oceans. Some of that water came from volcanic activity within the Earth, and some came from icy comets that struck the planet. So the ocean is both native to Earth and a gift from space. Every time you look at the sea, you're looking at water that's older than almost anything else on the planet's surface. Water that has been here through the entire history of life on Earth. Tides are caused by the gravitational pull of the moon and, to a lesser extent, the sun. As the moon orbits Earth, its gravity pulls on the water in the oceans, creating a bulge on the side of Earth facing the moon. There's also a bulge on the opposite side of Earth because of inertia. As the Earth rotates, different parts of the planet pass through these bulges, creating the regular rise and fall we call tides. Most coastlines experience 2 high tides and 2 low tides each day. The difference between high and low tide can be just a few inches in some places, or over 50 feet in places like the Bay of Fundy in Canada. Tides are one of the most predictable natural phenomena governed by the mathematical precision of celestial mechanics. Ancient peoples tracked the tides for fishing and navigation, and even today, they remain essential knowledge for anyone who works or plays on the ocean. There are places in the ocean called dead zones, where there's so little oxygen that most marine life cannot survive. These zones are usually caused by excessive nutrients, particularly nitrogen and phosphorus from agricultural runoff flowing into the ocean. This causes massive blooms of algae. When the algae die and decompose, the process consumes oxygen in the water, creating hypoxic conditions. Dead zones can cover thousands of square miles, and they're growing in size and number around the world. The Gulf of Mexico has a dead zone that forms every summer, sometimes covering an area the size of New Jersey. It's a reminder that what we do on land doesn't stay on land. The rivers carry our pollution to the sea, and the ocean pays the price. The ocean absorbs about 30% of the carbon dioxide humans produce. In one sense, this is beneficial because it slows the rate of atmospheric warming. But there's a cost. When CO2 dissolves in seawater, it forms carbonic acid, making the ocean more acidic. This process, called ocean acidification, is happening faster now than at any time in the past 300 million years. Acidic water makes it harder for creatures like corals, shellfish, and plankton to build their shells and skeletons from calcium carbonate. If acidification continues at the current rate, many of these creatures may not be able to survive, which would have cascading effects throughout the entire marine food web. The ocean has been absorbing our excess carbon, acting as a buffer, but it can't do so forever without consequences. There are rivers within the ocean. Not rivers of brine like we mentioned earlier, but massive currents that flow through the sea like rivers flow over land. The Gulf Stream, which we touched on before, is one of these. It carries about 4 billion cubic feet of water per second, which is more than all the rivers on land combined. The Kuroshio Current off Japan is another, carrying warm tropical water northward along the Asian coast. These currents are part of a global system called the thermohaline circulation, sometimes referred to as the ocean conveyor belt. This system moves water around all of Earth's oceans, driven by differences in temperature and salinity. Water warmed in the tropics flows toward the poles, where it cools, becomes denser, and sinks, then flows back toward the equator along the ocean floor. It can take 1,000 years for a single molecule of water to complete this journey. The ocean is patient, moving to rhythms far slower than our human lives. Seagrass meadows, though less famous than coral reefs, are equally important marine ecosystems. These underwater flowering plants grow in shallow coastal waters and provide crucial habitat for many species, including young fish, sea turtles, and manatees. Seagrass meadows also help protect coastlines from erosion by stabilizing sediment with their roots, and they improve water quality by filtering pollutants. Perhaps most impressively, seagrass meadows can capture carbon from the atmosphere up to 35 times faster than tropical rainforests. They store this carbon in their roots and in the sediment below them, sometimes for thousands of years. Despite their importance, seagrass meadows are disappearing rapidly due to coastal development, pollution, and warming waters. We're losing these underwater meadows before most people even know they exist. The Great Barrier Reef in Australia is the largest living structure on Earth. It's so large that it's visible from space. The reef is actually made up of nearly 3,000 individual reefs and 900 islands stretching over 1,300 miles. It's home to an incredible diversity of life, over 1,500 species of fish, 400 species of coral, 4,000 species of mollusks, and countless other creatures. Indigenous Australians have known and cared for the reef for over 60,000 years, and it holds deep cultural and spiritual significance for them. But the Great Barrier Reef is in trouble. Rising ocean temperatures have caused severe coral bleaching events in recent years, and scientists warn that without significant action to reduce greenhouse gas emissions, much of the reef could die within our lifetimes. It would be a loss not just for Australia, but for the entire world. Mangrove forests grow in coastal areas where saltwater and freshwater mix, places that would be too salty for most trees. Mangroves have evolved special adaptations to handle the salt. Some filter it out through their roots, others excrete it through their leaves. These trees grow in tangled, dense forests along tropical and subtropical coastlines, their roots creating a complex maze above and below the water. Mangrove forests are incredibly productive ecosystems, serving as nurseries for countless fish and crustacean species. They also protect coastlines from storm surges and erosion, and like seagrass meadows, they're excellent at capturing and storing carbon. Yet mangrove forests are being cleared at an alarming rate, mostly for coastal development and shrimp farming. We're removing one of the ocean's most effective natural defenses against storms and climate change. Some fish can change their sex. Many species of reef fish, including clownfish, groupers, and wrasses, are sequential hermaphrodites, meaning they start life as one sex and can change to the other under certain conditions. In clownfish communities, for example, there's typically one large female and one large male, along with several smaller males. If the female dies, the largest male will change sex and become female, and the next largest male will take over as the breeding male. This ability to change sex helps ensure the survival of the species by maintaining breeding pairs even when partners die. It's a reminder that nature is far more flexible and complex than we often assume. The categories we create don't always fit the reality of how life actually works. The ocean is filled with sounds we can't hear. Besides whale songs, there's the clicking of dolphins as they echolocate, the grunting of fish, the crackling of snapping shrimp, and even the sound of ice melting in polar regions. During World War II, sonar operators sometimes detected mysterious sounds they couldn't explain. One of these, called the bloop, was detected in 1997. It was an ultra-low frequency sound, loud enough to be picked up by sensors thousands of miles apart. For years, people speculated it might be some enormous unknown creature. Eventually, scientists determined it was most likely the sound of an ice quake, the fracturing and cracking of an Antarctic ice shelf. But the ocean still holds many mysterious sounds we haven't fully explained. There is a whole acoustic world beneath the waves that we're only beginning to understand. Jellyfish have been around for at least 500 million years, making them older than dinosaurs, older than trees, older than most forms of life on Earth. They've survived multiple mass extinction events that wiped out countless other species. Despite having no brain, no heart, and no bones, jellyfish are remarkably successful. They're found in every ocean, from the surface to the deep sea, from the tropics to the Arctic. Some jellyfish are tiny, barely visible to the naked eye. Others, like the lion's mane jellyfish, can have tentacles over 100 feet long. There are even jellyfish that appear to be biologically immortal. The Turritopsis dohrnii, sometimes called the immortal jellyfish, can revert back to its juvenile polyp stage after reaching maturity, potentially repeating this cycle indefinitely. They're strange alien creatures that remind us how diverse life can be. The ocean has its own forests. Kelp forests grow in cool, relatively shallow waters along many coastlines. Giant kelp, which grows along the Pacific coast of North America, can grow up to 2 feet per day, making it one of the fastest-growing organisms on Earth. A mature kelp forest can reach heights of over 100 feet, creating a dense underwater canopy that provides habitat for hundreds of species. Sea otters, seals, fish, octopuses, and countless invertebrates live in and around kelp forests. These ecosystems are incredibly productive, rivaling tropical rainforests in the amount of life they support. But kelp forests are sensitive to changes in water temperature and nutrient availability, and they're threatened by warming oceans and by the loss of sea otters, which keep sea urchin populations in check. Without otters, urchins can overgraze the kelp, creating what are called urchin barrens, underwater deserts where the kelp has been stripped away. Sea turtles have been swimming in the oceans for over 100 million years. They survived whatever killed the dinosaurs, and they've adapted to life in nearly every ocean. Sea turtles are remarkable navigators. Females return to the exact beach where they were born to lay their own eggs, sometimes traveling thousands of miles to get there. Scientists believe they navigate using Earth's magnetic field, essentially using an internal compass. Baby sea turtles, after hatching and making their dangerous journey from the beach to the sea, will spend years in the open ocean, riding currents and feeding on jellyfish and other prey. Then, when they're old enough, they return to coastal waters. Despite their ancient lineage and remarkable adaptations, all 7 species of sea turtles are now threatened or endangered, primarily due to human activities like fishing, plastic pollution, and coastal development. Dolphins are among the most intelligent animals on Earth. They have complex social structures, use tools, and can even recognize themselves in mirrors, a sign of self-awareness that very few animals possess. Dolphins communicate using a sophisticated system of clicks, whistles, and body language. Each dolphin has a unique signature whistle that functions like a name, and they use these whistles to call to each other. They hunt cooperatively, using strategies that they seem to plan and coordinate. In some parts of the world, dolphins have been observed working with human fishermen, herding fish toward their nets in exchange for a share of the catch. It's a partnership that has existed for generations in some places. Dolphins seem to enjoy the company of humans, often approaching boats and swimmers out of apparent curiosity. There's something about their playfulness and apparent joy that resonates with us deeply. The ocean is a treasure trove of human history. Besides the millions of shipwrecks, there are also submerged cities and settlements. Drowned when sea levels rose at the end of the last ice age, ancient ports, temples, and even entire coastal cities now lie beneath the waves. The Mediterranean alone is estimated to contain over 1 million archaeological sites. Off the coast of Egypt, the ancient cities of Canopus and Heracleion were discovered submerged in the 1990s, complete with temples, statues, and inscriptions. These underwater ruins provide invaluable insights into ancient civilizations, preserving artifacts in ways that wouldn't be possible on land. The water protects them from air and, in many cases, from human looting. Marine archaeologists are essentially time travelers, diving into the past to uncover secrets that have been hidden for thousands of years. Octopuses are masters of disguise and escape. They can change not only their color, but also their skin texture to match their surroundings in less than a second. This ability isn't just for hiding from predators. Octopuses also use it to communicate, flashing patterns across their skin to signal aggression, fear, or courtship. Their intelligence is remarkable. Octopuses can solve puzzles, navigate mazes, and use tools. They've been observed carrying coconut shell halves to use as portable shelters. In aquariums, they're notorious escape artists, able to squeeze through openings as small as their beak, which is the only hard part of their body. There are stories of octopuses escaping their tanks at night to raid neighboring tanks for food, then returning to their own tank before morning. They're solitary creatures with short lifespans, usually just a few years. Yet they exhibit behaviors that suggest curiosity, playfulness, and problem-solving abilities that rival some mammals. The Sargasso Sea is unique. It's the only sea on Earth that has no land boundaries. Instead, it's defined by 4 ocean currents that circulate around it: the Gulf Stream, the North Atlantic Current, the Canary Current, and the North Atlantic Equatorial Current. This creates a relatively calm region in the middle of the North Atlantic Ocean. The Sargasso Sea is named for the large masses of sargassum seaweed that float on its surface. This seaweed provides habitat for a unique community of marine life, including fish, turtles, birds, and countless invertebrates that live nowhere else. The Sargasso is also important as a spawning ground for eels. European and American eels travel thousands of miles to breed in the Sargasso. Then their larvae drift back to freshwater rivers and streams where they'll spend most of their lives. It's a mysterious, almost magical place, a sea within an ocean. Some fish can fly. Flying fish don't truly fly like birds, but they can glide impressive distances. When pursued by predators, they burst out of the water at speeds of up to 40 miles per hour and spread their enlarged pectoral fins like wings. They can glide for over 600 feet, occasionally beating their tails against the water's surface to gain more speed and extend their flight. It's a remarkable adaptation that helps them escape predators like tuna and dolphins. Watching a school of flying fish burst from the water and glide across the waves is one of the ocean's most beautiful sights, a moment when the boundary between sea and sky seems to dissolve. The ocean is home to the longest living animals known to science. The Greenland shark, which swims in the cold waters of the North Atlantic and Arctic Oceans, can live for over 400 years. One individual was estimated to be around 500 years old, meaning it was born around the time of Shakespeare. These sharks grow very slowly in the frigid waters and don't reach sexual maturity until they're over 100 years old. They move slowly, almost lethargically through the dark cold waters, feeding on fish and even sleeping seals. Many Greenland sharks are blind or nearly blind due to parasites that attach to their eyes, but this doesn't seem to hamper them much in the dark waters where they live. To think that a single animal could witness 5 centuries of change in the ocean is humbling. What would such a creature remember if it could remember? Rogue waves, also called freak waves, are massive waves that appear seemingly out of nowhere in the open ocean. For centuries, sailors reported encountering waves that towered over their ships, walls of water that appeared suddenly and without warning. These accounts were often dismissed as exaggerations or myths. But in 1995, a rogue wave was measured by scientific instruments for the first time when it struck an oil platform in the North Sea. The wave was 85 feet high. Since then, satellite observations have confirmed that these waves are real and more common than previously thought. They form through a combination of factors: waves from different storms converging, currents focusing wave energy, or through a quantum-like phenomenon where smaller waves temporarily combine to create a monster. Rogue waves are one of the ocean's many reminders that despite all our technology and knowledge, The sea remains dangerous and unpredictable. Fact 41. The ocean is a medicine cabinet we're only beginning to explore. Many important drugs have been derived from marine organisms. A compound from sea sponges led to the development of the antiviral drug used to treat herpes. A toxin from cone snails, which they used to paralyze prey, has been developed into a painkiller for humans. Researchers are studying everything from shark cartilage to sea cucumber compounds in the search for treatments for cancer, arthritis, and other diseases. The ocean's incredible biodiversity means it likely contains thousands of potentially useful compounds that we haven't discovered yet. But as marine ecosystems decline, we risk losing these natural pharmaceutical resources before we even know they exist. Every species that goes extinct takes with it unique chemistry, unique genetic information that might have held the cure for human diseases. Fact 42. The ocean is never truly still. Even on the calmest day, when the surface appears like glass, there's movement. Currents flow beneath the surface. Water molecules vibrate with thermal energy. Tides pull and push. On a molecular level, there's constant motion, constant change. This movement is essential. It circulates nutrients, distributes heat, and oxygenates the water, making life possible. A truly still ocean would be a dead ocean. The constant motion connects every part of the ocean to every other part, making it one vast, interconnected system. What happens in the Arctic affects the tropics. Pollution released into the ocean on one coast can travel to another continent. The ocean's movement makes it resilient in some ways, able to distribute and dilute impacts. But it also means that harm spreads widely. There's no isolated part of the ocean anymore. It's all one body of water, and what we do to one part, we do to the whole. Fact 43. Some sharks must keep swimming or they'll die. Species like the great white, the mako, and the whale shark are what's called obligate ram ventilators. They breathe by swimming forward with their mouths open, forcing water over their gills to extract oxygen. If they stop swimming, water stops flowing over their gills, and they suffocate. These sharks never truly sleep in the way we understand sleep. They may enter periods of reduced activity, but they never stop moving. Other shark species can pump water over their gills while resting on the bottom, giving them more flexibility. But for the obligate ram ventilators, life is constant motion, an endless journey through the blue. There's something both exhausting and beautiful about that. A life that is nothing but forward movement, never resting, always in motion like the ocean itself. Fact 44. The ocean has mountains of garbage in it. There are 5 major ocean gyres, massive rotating current systems that tend to concentrate floating debris. The largest of these garbage patches is in the North Pacific, an area sometimes called the Great Pacific Garbage Patch. It's not a solid island of trash like some people imagine, but rather a vast area where plastic particles float in the water column and on the surface at concentrations higher than surrounding waters. The patch is estimated to cover an area twice the size of Texas. Most of the plastic is broken down into tiny pieces called microplastics, small enough to be eaten by fish and other marine life, entering the food chain and eventually reaching our own plates. Every year, millions of tons of plastic enter the ocean. It breaks down into smaller and smaller pieces, but never truly goes away. We've created something virtually permanent and spread it throughout the ocean, into even the deepest trenches and most remote waters. Fact 45. There are creatures in the deep ocean that look like they're from science fiction. The barrel-eye fish has a transparent head, and its tubular eyes look straight up through the top of its skull, watching for the silhouettes of prey above. The vampire squid isn't actually a vampire and isn't quite a squid either, but something in between, with webbing, that connects its arms like a dark cloak. The gulper eel has a mouth that can open wide enough to swallow prey larger than itself, and a long whip-like tail that glows at the tip. These creatures have adapted to life in an environment so extreme, so different from the surface, that they've evolved forms that seem almost alien. Yet, they're just as much a part of Earth's story as we are, just as shaped by evolution and time, just living in a part of the world we rarely see. The ocean floor contains more history than all the museums in the world combined. Every shipwreck is a time capsule. Every sediment layer is a record of past climates. Scientists can drill into the ocean floor and pull up cores of mud and rock that tell stories going back millions of years. They can read in these cores the history of ice ages, volcanic eruptions, asteroid impacts, and the slow drift of continents. The deepest ocean sediments contain microfossils from creatures that lived when the dinosaurs roamed. In some places, the sediment is over half a mile thick, representing hundreds of millions of years of accumulation. It's a library written in mud and stone, and we're only just learning how to read it. Seahorses are one of the ocean's most unusual fish. They swim upright, have prehensile tails like monkeys, and it's the males that get pregnant and give birth. A female seahorse deposits her eggs into the male's brood pouch, where he fertilizes them and carries them until they're ready to be born. When the babies emerge, sometimes hundreds at a time, they're perfect miniature versions of their parents, just a few millimeters long. Seahorses are also one of the few fish species that mate for life, performing elaborate courtship dances with their partners each morning. They're terrible swimmers with tiny fins that flutter rapidly but move them slowly through the water. Instead of chasing prey, they anchor themselves to seagrass or coral with their tails and wait for small crustaceans to drift by, which they suck up through their tubular snouts like living vacuum cleaners. We're at 50 facts now, halfway through our journey. Take a deep breath. Feel the weight of your body sinking into your bed. Imagine you're floating on calm water held up by the sea, perfectly safe. The ocean contains mountains of treasure that we'll probably never find. Over the centuries, thousands of ships laden with gold, silver, and precious gems have sunk in storms or battles. The total value of treasure on the ocean floor is estimated to be in the billions of dollars, possibly much more. Spanish galleons returning from the New World with holds full of silver coins. Pirate ships with stolen loot. Merchant vessels carrying trade goods and currency. Most of it lies in places too deep or too remote to be economically recoverable. Even when treasure hunters do locate wrecks, salvage operations are incredibly expensive and complicated. So the treasure sits there, scattered across the ocean floor, guarded by the sea itself, waiting in the darkness. Anglerfish are perhaps the strangest-looking creatures in the ocean. The females have a modified spine that extends from their heads like a fishing rod, tipped with a bioluminescent lure. They wave this glowing lure in the darkness to attract prey, and when something comes close enough to investigate, the anglerfish strikes with lightning speed. But it's the anglerfish's reproduction strategy that's truly bizarre. The males are tiny, sometimes 100 times smaller than the females. When a male finds a female in the vast darkness of the deep sea, he bites onto her and fuses with her body, permanently. His organs degenerate until he's nothing but a pair of gonads, providing sperm whenever the female needs to reproduce. Some females have been found with multiple males fused to their bodies. It's an extreme solution to the problem of finding a mate in the enormous, dark expanse of the deep ocean. Coral isn't a plant, and it's not a rock either. Each coral is actually a colony of tiny animals called polyps, related to jellyfish and sea anemones. These polyps secrete calcium carbonate skeletons, and over time, these skeletons build up into the massive structures we call coral reefs. But the polyps can't do it alone. Living inside their tissues are microscopic algae called zooxanthellae, which photosynthesize and share the energy they produce with the coral. In return, the coral provides the algae with a safe place to live and access to sunlight. It's a partnership that has existed for millions of years, and it's what makes coral reefs possible. When corals bleach, it's because this partnership has broken down. The stressed coral expels the algae, losing both its color and its primary food source. If the stress continues, the coral starves. The ocean has its own lakes of liquid asphalt. In the Gulf of Mexico and off the coast of Trinidad, there are places where natural asphalt seeps up from the seafloor, forming pools of thick black tar. These asphalt lakes are toxic to most life, but some bacteria thrive there, feeding on the hydrocarbons. Scientists study these bacteria because they might be similar to life forms that could exist on other worlds, like Saturn's moon Titan, which has lakes of liquid methane. The asphalt lakes also preserve things remarkably well. Researchers have found the remains of extinct Ice Age animals trapped in the asphalt, animals that fell into these natural tar pits thousands of years ago when sea levels were lower and the asphalt was exposed on land. Sperm whales are the deepest diving mammals on Earth. They can dive to depths of over 6,000 feet and hold their breath for over an hour. They make these extreme dives to hunt their favorite prey, giant squid. The battles between sperm whales and giant squid happen in complete darkness, at depths where the pressure would crush a human instantly. We've never witnessed one of these encounters, but we know they happen because sperm whales often bear circular scars from squid suckers on their skin. The whales use echolocation to find their prey in the darkness, producing the loudest sounds of any animal on Earth, clicks so powerful they could theoretically vibrate a human to death at close range. But sperm whales are gentle with humans, showing curiosity rather than aggression when divers encounter them. Horseshoe crabs have been around for over 450 million years, making them older than trees, older than dinosaurs, older than most life on land. They're sometimes called living fossils because they've changed so little over that time. Despite their name, they're not actually crabs. They're more closely related to spiders and scorpions. Horseshoe crabs have blue blood, and this blood has a remarkable property. It clots immediately when it comes into contact with bacterial toxins. Scientists harvest this blood to create a test that ensures vaccines and medical devices are free from contamination. Every vaccine you've ever received was tested using horseshoe crab blood. The crabs are usually returned to the ocean after their blood is collected, but the practice is controversial, and scientists are working on synthetic alternatives. The ocean's deepest points are called Hadal zones, named after Hades, the Greek underworld. These are the depths beyond 20,000 feet, found only in the deepest ocean trenches. Until recently, scientists believed nothing could live at such depths. The pressure is over 1,000 times greater than at sea level. There's no light, no photosynthesis, very little food. But expeditions to these depths have found thriving communities of amphipods, snailfish, and other creatures perfectly adapted to these extreme conditions. These animals have special proteins that prevent their cells from being crushed, and their bodies contain very few air spaces. Some of the deepest fish ever found were snailfish living at over 26,000 feet in the Mariana Trench. Life, it turns out, can exist anywhere there's liquid water and some source of energy, no matter how extreme the conditions. The Mediterranean Sea was once completely dry. About 6 million years ago, the Strait of Gibraltar closed, cutting off the Mediterranean from the Atlantic Ocean. The Mediterranean, fed only by rivers and with high evaporation rates, dried up almost completely in perhaps less than 1,000 years. It became a vast desert basin with a few hypersaline lakes scattered across its floor, lying more than a mile below global sea level. This lasted for hundreds of thousands of years until the Gibraltar Strait reopened, and the Atlantic came pouring back in through what must have been the largest waterfall in Earth's history. Water cascaded into the Mediterranean basin at a rate 1,000 times greater than Niagara Falls, and it took perhaps 100 years to refill the entire sea. The salt deposits left from that dry period are still buried beneath the Mediterranean floor today, evidence of one of the most dramatic transformations any ocean has ever undergone. That's 60 facts. Your breathing has probably slowed by now. That's good. That's exactly what should be happening. Let the ocean carry you wherever you need to go. Sea ice in the Arctic and Antarctic plays a crucial role in Earth's climate. Ice reflects sunlight back into space, helping to keep the planet cool. As ice melts and turns into dark ocean water, that water absorbs heat instead of reflecting it, which causes more warming, which melts more ice. It's a feedback loop that's accelerating Arctic warming. The Arctic is warming about twice as fast as the rest of the planet, and summer sea ice has declined by about 40% since satellite measurements began in the 1970s. This isn't just an Arctic problem. The loss of sea ice affects weather patterns around the entire northern hemisphere, potentially contributing to extreme weather events far from the poles, and it affects the creatures that depend on ice. Polar bears hunt seals from the ice. Walruses rest on it. Many species of seals breed on it. As the ice disappears, these animals are running out of habitat. Narwhals are real animals, not mythical unicorns, though they inspired the unicorn legends. These Arctic whales have a long spiral tusk that can grow up to 10 feet long. For centuries, people believed these tusks came from unicorns. In medieval Europe, narwhal tusks were worth many times their weight in gold. But the tusk is actually a tooth, and its purpose remained a mystery for a long time. Scientists now believe it's a sensory organ packed with millions of nerve endings that can detect changes in water temperature, salinity, and pressure. Male narwhals sometimes sword fight with their tusks, though they don't seem to seriously injure each other. These strange, elusive whales live in some of the most remote and harsh environments on Earth, spending their entire lives in the icy waters of the Arctic, rarely seen by humans. The ocean is full of animals that form partnerships. Clownfish live among sea anemones, protected by the anemone's stinging tentacles, which don't affect the fish. In return, the clownfish defends the anemone from predators and may provide nutrients through its waste. Cleaner fish and cleaner shrimp set up cleaning stations where larger fish come to have parasites removed. The large fish could easily eat the cleaners, but they don't. They wait patiently while the cleaners work, sometimes even opening their mouths so the cleaners can pick parasites from their teeth and gills. Some species of gobyfish share burrows with nearly blind shrimp. The shrimp maintains the burrow, while the fish stands guard at the entrance, warning the shrimp of danger with a flick of its tail. These partnerships show that cooperation and mutual benefit are just as important in nature as competition and predation. There are places in the ocean that glow at night. Bioluminescent plankton, when disturbed, emit blue-green light through chemical reactions. In some coastal areas, particularly in warm tropical waters, these plankton can be so abundant that any movement through the water creates trails of light. Dolphins swimming at night leave glowing wakes. Waves breaking on shore sparkle and shimmer. Even raindrops hitting the surface create tiny bursts of light. It's called bioluminescent bay phenomenon, and there are a few places in the world, like Vieques in Puerto Rico or the Maldives, where it's particularly spectacular. You can wade into the water at night and watch your hands and feet glow with every movement. It's like swimming through liquid starlight, one of the most magical experiences the ocean can offer. Orcas, also called killer whales, aren't whales at all. They're the largest members of the dolphin family. They're also one of the most widespread mammals on Earth, found in every ocean from the Arctic to the Antarctic. But different populations of orcas are so specialized that they're almost like different species. Some eat only fish, particularly salmon. Others hunt marine mammals like seals and sea lions. Some have even learned to hunt great white sharks, flipping them upside down to induce a state called tonic immobility, then eating only the liver. Orcas are incredibly intelligent, with complex social structures and cultures. Different pods have different dialects in their vocalizations, and they pass hunting techniques from generation to generation. They're apex predators, with no natural enemies except humans, yet there's never been a confirmed fatal attack on a human in the wild. The ocean floor is covered with nodules. These are lumps of metal ore, usually about the size of potatoes, containing manganese, nickel, copper, and cobalt. They form incredibly slowly, growing by tiny fractions of an inch every million years, as metals precipitate out of seawater onto the nodules' surfaces. Despite their slow formation, they cover vast areas of the deep ocean floor, particularly in the Pacific. Mining companies are interested in harvesting these nodules for their valuable metals, but scientists warn that mining could devastate deep-sea ecosystems that we barely understand. The question of whether to mine the deep ocean floor is one of the big environmental debates of our time, balancing human need for resources against the protection of pristine and largely unknown environments. Some fish are born female and become male as they grow larger. Others are born male and become female, and some fish can switch back and forth multiple times during their lives, depending on social conditions. The bluehead wrasse, for example, lives in groups with one dominant male and many females. If the male dies, the largest female will begin to change sex, developing male coloration and behavior within hours and completing the physical transformation within a couple of weeks. Sex in the ocean is far more fluid than most people realize, and it challenges our assumptions about how gender and reproduction must work. Nature doesn't follow our rules. It finds whatever solutions work for survival and reproduction, no matter how strange they might seem to us. 70 facts behind us now. The ocean stretches on, deeper than mountains are tall, wider than continents, and you're floating here with me, safe and warm, listening to these stories. Ancient sailors navigated by the stars, but they also read the ocean itself. They watched cloud patterns which differ over islands compared to open ocean. They observed the behavior of birds which fly toward land at dusk and toward fishing grounds at dawn. They felt the rhythm of swells and waves which have different patterns depending on whether they're generated by local winds or by distant storms. They noticed the color of the water and the types of seaweed floating in it. Polynesian navigators could identify islands hundreds of miles away by the wave patterns reflected off them. This knowledge was passed down through generations, not written in books, but memorized through chants and stories. It's a way of knowing the ocean that we've largely lost in the age of GPS and charts, but it reminds us that there are many ways to understand the sea, not all of them involving instruments and measurements. The ocean has weather, but it also has climate patterns that last for years or decades. El Niño and La Niña are the most famous of these. Every few years, water temperatures in the tropical Pacific shift. During El Niño, warm water that's normally in the western Pacific spreads eastward toward South America. This seemingly small change affects weather around the entire world. It can bring flooding to some regions and drought to others. It affects hurricane formation, winter temperatures in North America, and fish populations along the coasts. La Niña is the opposite pattern, with cooler than normal water in the eastern Pacific, and it has its own set of global effects. Scientists are still working to understand and predict these patterns, but we know they're natural cycles that have been happening for thousands of years, part of the ocean's own rhythm. Hagfish are among the ocean's strangest and most disgusting creatures. They look like eels, but they're not fish at all. They're jawless and boneless, with skulls made of cartilage and bodies that feel like living slime. When threatened or when feeding, hagfish produce enormous quantities of slime, a sticky, expanding goo that can clog the gills of predators. A single hagfish can turn a bucket of water into slime in seconds. They feed on dead and dying creatures on the ocean floor, burrowing into carcasses and eating them from the inside out. Despite being gross by human standards, hagfish play an important role as scavengers, recycling nutrients back into the ocean ecosystem. And their slime is so unique that scientists are studying it to create new materials, possibly including synthetic fibers stronger than spider silk. The ocean contains underwater waterfalls, though they're not made of water falling through air. They're made of dense water flowing over underwater cliffs and into deeper basins. The largest of these is in the Denmark Strait between Greenland and Iceland. Cold, dense water from the Nordic seas flows over an underwater ridge and plunges down into the deep Atlantic, falling more than 2 miles. This underwater cataract carries about 175 million cubic feet of water per second, which is more than 2,000 times the flow of Niagara Falls. These underwater cascades are important for the global ocean circulation, helping to drive the currents that redistribute heat around the planet. The ocean is getting louder, and this is a problem for the animals that live there. Ships, oil and gas exploration, military sonar, and other human activities have made the ocean much noisier than it was a century ago. In some parts of the ocean, noise levels have increased by 30 decibels, which is a 1,000-fold increase in sound intensity. For animals like whales and dolphins that rely on sound to communicate, navigate, and find food, this noise pollution can be debilitating. It's like trying to have a conversation in a nightclub where the music is so loud you can't hear the person next to you. Whales have been found to change their calling patterns in response to noise, calling more loudly or at different frequencies. But there's a limit to how much they can adapt, and noise pollution may be interfering with crucial behaviors like mating and migration. The Monterey Bay Aquarium has a webcam trained on their kelp forest exhibit, and sometimes, late at night, viewers have reported seeing strange, unidentified creatures in the tank. The ocean is full of species that science hasn't formally described yet. New marine species are discovered every year, sometimes in the deep sea, sometimes right in coastal waters that have been studied for centuries. In 2020, scientists identified a new species of whale, Omura's whale, that had been overlooked for decades because it was confused with other similar species. There may be thousands of species of fish alone that we haven't discovered yet, not to mention invertebrates, microbes, and other forms of life. The ocean still holds so many secrets, so many creatures living their lives completely unknown to us. 90 facts now. Just 10 more, and then you can rest. Or you can rest now. The ocean gives you permission to rest whenever you're ready. The ocean is divided into zones based on depth, and each zone is like a different world. The midnight zone below about 3,000 feet is the largest habitat on Earth by volume. It's always dark, always cold, around 40 degrees Fahrenheit, and the pressure is crushing. Yet more fish live in the midnight zone than in all the other ocean zones combined. We've barely explored this zone. Every expedition finds new species, new behaviors, new phenomena that challenge our understanding. The midnight zone might contain more biodiversity than any other environment on Earth, and we've only just begun to discover it. Barnacles are crustaceans, related to crabs and shrimp, though you'd never guess it from looking at them. They start life as free-swimming larvae, but eventually they find a suitable surface, a rock, a pier, a ship's hull, or even a whale's skin, and they cement themselves in place head first. They build a volcano-shaped shell around their bodies and spend the rest of their lives standing on their heads, kicking their feathery legs out of the shell to catch passing food particles. Once attached, they never move again. Some barnacles can live for 20 years or more. In the age of sail, barnacles growing on ships' hulls would slow them down significantly, and scraping barnacles off the hull was a regular and hated chore for sailors. The ocean makes its own gold. Dissolved in seawater are traces of gold, about 10 parts per trillion. It doesn't sound like much, but when you consider how much water is in the ocean, it adds up to millions of tons of gold dissolved in the sea. There have been various schemes over the years to extract this gold, but it's never been economically viable. The concentration is just too low, and the cost of processing enough seawater to extract meaningful amounts of gold is higher than the value of the gold itself. So the gold remains, dissolved and dispersed, part of the ocean's chemistry, making the sea slightly more precious in a literal sense. Dolphins sleep with only half their brain at a time. They need to remain conscious even while sleeping because they have to come to the surface to breathe. If they fell completely asleep like we do, they'd drown. So they've evolved a remarkable adaptation called unihemispheric slow-wave sleep. One half of the brain sleeps while the other half stays alert, maintaining enough consciousness to swim and breathe. Then they switch, giving the other half of the brain a chance to rest. This means dolphins are, in a sense, never fully asleep and never fully awake. They exist in an in-between state that we can barely imagine. The deepest point in the ocean that we know of is the Challenger Deep in the Mariana Trench at nearly 7 miles down. Only 4 people have ever been there: Jacques Piccard and Don Walsh in 1960, James Cameron in 2012, and Victor Vescovo, who has made multiple dives since 2019. More people have been to the moon than to the deepest part of the ocean. When Piccard and Walsh reached the bottom, they saw a flatfish and a shrimp. proving that life exists even in the most extreme environment on Earth. When plastic bags and candy wrappers were found at similar depths in other trenches, it proved that human pollution has reached even there, to places where almost no humans have ever been. Humpback whales sing complex songs that can last for hours. Only the males sing, and all the males in a population sing roughly the same song, though it evolves and changes over time. A song that's popular one year might be modified or replace the next. The songs are some of the most complex non-human vocalizations in the animal kingdom, with repeating themes and structures that almost seem like music. Scientists don't know exactly why humpbacks sing. It might be to attract mates, or to assert territory, or to communicate across long distances. But there's something haunting and beautiful about these songs, something that touches humans who hear them, even though we don't understand what they mean. Seabirds like albatrosses spend most of their lives flying over the open ocean, sometimes traveling thousands of miles without touching land. They can lock their wings in an extended position and glide for hours without flapping, using wind currents that blow over the waves. Wandering albatrosses have the longest wingspan of any living bird, over 11 feet, and they can fly for thousands of miles on a single foraging trip. They only return to land to breed, finding their way back to the same island, even the same nest site where they were born. How they navigate across vast expanses of featureless ocean is still not entirely understood, but they probably use a combination of visual cues, magnetic fields, and even smell to find their way home. Remoras are fish that have evolved a suction disc on top of their heads, which they use to attach to sharks, whales, manta rays, and even boats. They get free transportation and feed on scraps from their host's meals. The relationship is mostly commensal, meaning the remora benefits while the host is neither harmed nor helped, though sometimes remoras may clean parasites from their hosts. Interestingly, remoras are very picky about what they attach to. They seem to prefer certain species and even certain individuals. Researchers have found that remoras have preferences based on their host's swimming style and behavior. It's a strange life being a hitchhiker in the ocean, but it's clearly a successful strategy. Remoras are found in all the world's tropical and temperate oceans. Sea cucumbers are among the ocean's most important recyclers. These soft-bodied creatures crawl slowly across the seafloor, consuming sediment and digesting the organic matter in it, then excreting clean sand. A large sea cucumber can process dozens of pounds of sediment per year. In some ecosystems, sea cucumbers are so abundant and so efficient at processing sediment that they turn over the entire top layer of the ocean floor every few years. This bioturbation, as scientists call it, is crucial for keeping nutrients cycling through the ecosystem. Some sea cucumbers have an unusual defense mechanism. When threatened, they can expel their internal organs through their anus, distracting predators while the sea cucumber escapes. Don't worry, they can regenerate their organs over the following weeks. Sea otters are one of the few mammals that use tools. They carry rocks on their chests and use them to crack open shellfish. They're also crucial to the health of kelp forests. Sea otters eat sea urchins, and sea urchins eat kelp. Without otters to keep urchin populations in check, the urchins can destroy entire kelp forests. When otters were hunted nearly to extinction for their fur in the 18th and 19th centuries, kelp forests along much of the Pacific coast collapsed. When otters were reintroduced and protected, the kelp forests recovered. It's one of the clearest examples we have of what ecologists call a keystone species, a species whose impact on its ecosystem is disproportionately large compared to its abundance. Sea otters also have the densest fur of any mammal, with up to 1 million hairs per square inch, because unlike other marine mammals, they don't have blubber to keep them warm. We're at 80 now. 20 left, but there's no finish line we're racing toward. The ocean doesn't end. These facts are just drops in an infinite sea. The ocean influences our language and culture in countless ways. We talk about the tip of the iceberg, meaning we're only seeing a small part of something because 90% of an iceberg's mass is underwater. We say we're feeling under the weather, a phrase that comes from sailors who would go below deck when storms approached. When we're learning something, we might dip our toe in to test the waters. We speak of waves of immigrants, of political tides turning, of being anchored to a place or adrift in life. The ocean has shaped human history and human thinking so profoundly that we carry it in our words, even when we're far from any coast. Whale falls are an important deep-sea phenomenon. When a whale dies and its body sinks to the ocean floor, it becomes an oasis of food in the nutrient-poor deep sea. A single whale carcass can support a unique ecosystem for decades. First come the mobile scavengers like hagfish and sharks, which strip away the soft tissue. Then come worms and crustaceans that colonize the bones, and bacteria that break down the lipids stored in the bones. Some species of worms and mollusks are found nowhere else except on whale falls. Scientists have discovered over 100 species that depend on whale falls, and they estimate that at any given time, there are thousands of whale falls scattered across the deep ocean floor. Stepping stones of life in the darkness. The ocean is a time machine. Light from the sun takes 8 minutes to reach Earth, so when you look at the sun, you're seeing it as it was 8 minutes ago. But light travels slowly through water. In the clearest ocean water, light can penetrate to maybe 800 feet before it's completely absorbed. But most ocean water is not that clear, and in many places, darkness begins at just a couple hundred feet. This means that in the deepest parts of the ocean, the water molecules have never seen sunlight in millions of years. The water in the deep ocean is ancient. Some of it lasts at the surface before humans existed. When deep ocean currents finally bring that water back to the surface, it's like a message from the past, carrying dissolved minerals and nutrients from centuries or millennia ago. Electric eels aren't eels at all. They're actually a type of knifefish more closely related to catfish. And they don't live in the ocean, they live in freshwater rivers in South America. But there are truly electric fish in the ocean, like electric rays, which can generate shocks of up to 200 volts. They use this ability to stun prey and defend against predators. The electricity is generated by specialized cells called electrocytes, which work like biological batteries. Electric rays have been known since ancient times. Ancient Greek and Roman physicians used their shocks to treat headaches and gout, making electric rays the first electrical medical devices, thousands of years before we understood what electricity actually was. Sponges are animals, not plants, though they don't look or act like most animals. They have no brain, no nervous system, no organs at all. They're essentially colonies of cells organized around a system of channels and pores. Water flows through these channels, and the sponge filters out bacteria and organic particles to eat. A single sponge can filter thousands of gallons of water per day. Some sponges live for thousands of years. A glass sponge found in Antarctic waters was estimated to be over 15,000 years old, making it one of the longest-lived organisms on Earth. It was already ancient when the pyramids were being built. Sponges are also chemical factories, producing compounds to defend against predators and fight off infections. Many of these compounds are unique and have potential medical uses. Parrotfish are crucial to coral reef health, but not in the way you might expect. They eat algae that grows on corals and rocks, scraping it off with their powerful beak-like teeth. This keeps the algae from overgrowing and smothering the coral. But parrotfish also eat coral itself, biting off chunks of the reef and grinding them up to digest the algae growing inside. The calcium carbonate that they can't digest gets excreted as sand. A single large parrotfish can produce hundreds of pounds of sand per year. Those beautiful white sand beaches in the tropics, a lot of that sand has passed through the digestive system of parrotfish. You're literally walking on fish poop, and it's one of the most beautiful substances on Earth. The ocean has a memory. Because water heats up and cools down slowly, the ocean responds to climate changes years or even decades after they occur. The heat that the ocean is absorbing today from increased greenhouse gases will continue affecting ocean temperatures for generations. Even if we stopped all carbon emissions tomorrow, the ocean would continue warming for decades because it's still responding to past emissions. This thermal inertia means that many of the impacts of climate change on the ocean are already locked in, already inevitable. But it also means that the actions we take today will affect the ocean for generations to come. We're not just making choices for ourselves, but for our children and grandchildren, and their children. 99. Almost there. But the ocean continues beyond numbers, beyond counting. The ocean is not really one ocean, but 5, the Pacific, Atlantic, Indian, Southern, and Arctic. But these divisions are human constructs. The ocean doesn't recognize these boundaries. Water flows freely between them, carried by currents and tides. A water molecule that starts in the Pacific might end up in the Atlantic decades later. The ocean is one continuous body of water, covering most of our planet, connected in ways we're still mapping and understanding. When you put your hand in the ocean anywhere on Earth, you're touching water that connects to every coast, every island, every marine ecosystem on the planet. The ocean is the thing that makes our world one world, and here we are at 100, but this isn't really an ending. The ocean has no ending. It goes on past the horizon, deeper than we can see, full of wonders we haven't discovered, and some we never will. The ocean was here long before us and will be here long after. It's the source of life on Earth and the keeper of mysteries we may never solve. Tonight, as you drift off to sleep, you can imagine yourself floating on gentle swells, held up by the sea, rocking slowly in a rhythm older than memory. The ocean is vast and you are small, but the ocean holds you anyway. It holds all of us, all life, everything we've ever known. We came from the sea billions of years ago, and in a way we carry it with us still. The salt in your blood is the same concentration as ancient seas. Your body is mostly water. You are, in a very real sense, a small piece of the ocean that learned to walk on land. Rest now. Let the waves carry you. The ocean will still be here in the morning, vast and patient and full of secrets. Sleep well, friend. Thank you for journeying with me tonight through these 100 ocean facts. May your dreams be as deep and peaceful as the sea.